binomial radical expressions. So this is going to be the next section with radicals that we're going to be doing. Okay, we'll turn this down so we can see a little better. And we need to first remind ourselves what a binomial is. Okay, so I want you to look at those problems that are numbered 4 through 7 for whatever reason, and I want you to decide which one is a binomial. So look at those expressions. Is there 1, 2, 3, or all 4 binomials? What's a binomial? Go ahead, Chris.
That's an expression with
They don't have to have 2 variables, but there's 2 something, I agree. 2 what? Go ahead, just show me. The what, honey? There's 2 terms. He's exactly right. There are 2 terms. And which one of these, is there one or more that has 2 terms? Number 6. That one is a binomial. I agree. Okay. What is number 4? Trinomial. Okay. How about number 5? I don't see any. I see a negative, which means you want to think that if there was a number in front, like a 1 or something like that, then I would agree. But that's just a negative sign, not a subtraction sign. So this is just a monomial. Okay? And then how about number 7? That's a trinomial again. Okay? So we're really going to be concerned today with binomials, okay, where we have 2 expressions that are connected with a plus or a minus sign. And we're going to be using radicals with them. So this is the formula for it. You can write it down if you want. Sometimes I think when you see the formulas with A's and B's and X's, it's a little confusing. So it might be beneficial to write the example down. But let me explain what this formula is actually saying. Notice what's true about the indexes. What has to be true in order to add the radicals? Have to be the same. Not even, but the same. Okay? Even means 2, 4, 6. We want them to be exactly the same. Now, if I have 2 radicals where what's underneath the radical is also the same, so not only are the indexes the same, but what's underneath is the same, I can rewrite those. We can think of those as like terms, okay? And what I can do is I can take those numbers out in front and just add them together. So for example, if I had the square root of 2 plus 3 square roots of 2, I can add those together because the square root of 2 is like a like term. What do I end up adding together? Well, I keep the square root of 2, but what do I do with the numbers out in front? These numbers out in front, I'm going to do what with? Nope. I'm going to add them because of the plus sign. Louise, you have a new seat, baby. Let me see where you sit. So I'm going to add the numbers in front. The problem is, in the first one, what number do you see in front? What number is there? It's a 1. Okay? So this is like a 1 in front. So what am I going to do? 1 plus 3. So what's my final answer? 4 radical 2. So in order to combine or add radicals, we need to make sure that what's underneath the radical is the same. The indexes have to be the same. And I just keep that. It's kind of like x plus 3x, which is 4x, right? It's the same kind of idea here. Okay? And we can do the same thing over on the right side here in the notes in terms of if we subtracted them. So for example, if I had 4 square roots of 3 minus 7 square roots of 3, what would my answer be? Can I subtract them? Can I go from a binomial to a monomial? Sure. They are like terms. So I have the square root of 3 here. And what do I do with the 4 and the 7? The 4 minus the 7? Negative what? Negative 3. Negative 3 radical 3. Okay? So again, if they're like terms, if what's underneath the radical is the same, we're in business. Okay? So let's look at this first example here. I'm going to highlight it. You don't need to write it down right now. I just want you to look at it. Can I combine those radicals? Travis, nobody looks at their crotch and smiles unless you got your phone out. Put it away. Okay? Put it away. Is it totally away now? Okay. Am I allowed to, can I add or subtract those radicals? Yes or no? No, I cannot. Why not? Say it louder.
The index is not the same.
The indexes are not the same. So we have the one index is a 3. What's the other index? It's a 2. If you don't see it there, it's a 2. So you can't combine them. They're not like radicals. So in other words, we cannot, they're not like radicals. It is as far as simplified as I can go. I can't combine, I can't get any more simplified than that. How about on the right-hand side? How about this example I'm going to highlight in blue? Are they like radicals? Is what's underneath the radical the same, and is the index the same? Yes. So they are alike, okay? Can I simplify it? Is it simplified? No, it's not. I can simplify it. And how do I do that? This one looks a little different. Well, I'm going to leave what's underneath the radical the same, and then what do I do with the numbers in the front? So what is 3x plus 4x? 7x. There's my answer. Okay? So even if we have variables, it's okay. We're good. Any questions so far? Not bad? Good. All right. Now, let's look at this example. And I definitely think this is one you need to put in your notes. Okay? Because this is one, this is a trinomial right now, I agree. But we are going to go ahead and try to combine and simplify that as much as possible. Right now, can I add or subtract these radicals? Not now. Well, maybe it's a great answer, because one, I know the indexes are the same, but what's the problem with the way it sits right now? The subtraction doesn't bother me. What bothers me? All 3 is the index, but there you go. The number under the radical is different. So I'm going to try to simplify each of these radicals first to see if I can't get what's underneath the radical to be the same. And then if it is, then I'm going to add or subtract. So I'm going to pause the recording. You guys know how to do this. I want you to go ahead and make factor trees for 250, 54, and 16, and reduce all 3 of those radicals individually. Okay? So I'm going to turn the lights back up, and you guys try this. So it looks to me like most of us got this. 5 times what is 250? 5 times what? 50, right? And then we have 5 times 10, 5 times 2. We're looking for groups of 3 because the index is 3. So a 5 comes out, and we're left with a 2 underneath. So the cube root of 250 is 5 cube roots of 2. Okay? Now when we're looking at 54, 2 times what is 54? Because it's the cube root. The index doesn't ever change. So if it starts as a 3, it ends as a 3. 27, okay. And then 3 times 9, and then 3 times 3. And again, I'm looking for groups of 3. So the cubed root of 54 is going to be 3 cube roots of 2, because the 2 is left over. All right, and then the last one here, 2 times what is 16? 8. And then we have 2 times 4, 2 times 2. We're looking again for a group of 3. So a 2 is going to come out for the cube root of 16. We're going to have 2 cube roots of 2. Okay? So what I want to do is, if you notice at this point, we have, this is our answer, correct? But it's not simplified yet. Why not? This is not completely simplified, what I just circled. It is what we have, but if you notice what's underneath the radical, it's the same now, isn't it? Isn't it all cube roots of 2? So that means I can just simply add or subtract the numbers in the front, the coefficients. So I'm going to add 5 plus 3 minus 2. So I get 6 cube roots of 2. That is the final answer. Now this is one that you could check on your calculator because I don't have any x's or y's, and I could, so I want you to check it. So let's go ahead and plug in the original problem, the cube root of 250, I want you to plug it in because I want you to see what it's going to look like. Do you know how to plug in the cube root of 250? Where is the cube root? Where can I find it on my calculator? Okay, so go to math and then option 4. So the cube root of 250, you have to arrow to the right to get the radical to stop, plus math again, cube root of 54, arrow to the right to get out of the radical, minus the cube root of 16. And you're going to get some kind of crazy number. What am I looking for to check to make sure my answer is correct? I'm going to plug in what we got as our answer to see if I get that same crazy decimal. So I'm going to plug in 6 and then go to math, cube roots of 2. And I should get exactly the same answer. And I did. So I know I did it right. Okay? Doing okay so far? Okay, do you understand how I got these 3 numbers, honey? Okay, all I did was I took the 5, the 3, and the 2. And if you look at the original problem, it was plus and then minus. 5 plus 3 is 8, minus 2 is 6. Okay? As soon as I reduced it, so what's underneath the radical was the same, I can combine them because they're like terms now. Okay? All right, last thing we're going to do, and then I'm going to give you guys some problems to work on. Last new thing is multiplying these binomial expressions. Okay? So let's look at this last problem. This is definitely one to include into your notes as well. What makes these binomial expressions, by the way? What makes them binomial? There's 2 terms, right? And we're just going to multiply them together. And we're going to multiply them like I've multiplied any other binomials. Back when we were doing it with quadratic equations, we would multiply them using this FOIL technique, first, outer, inner, last. Or sometimes your teacher just distributed everything. Same thing. If we look at this example here, I'm going to take the 3, and I'm going to multiply it by the 2, and multiply it times the 4 radical 5. 3 times 2 plus 3 times 4 radical 5. Then I'm going to take the 2 radical 5 and multiply it times the 2 and times the 4 radical 5. That's all I've done so far. Okay? So this first term, this first one here, is the one that is correct. Doesn't matter about FOIL method. I don't really care, right? First, 3 times 2, 3 times 4 radical 5, 2 radical 5 times 2. That's fine. Okay. It's the same thing. So, how do I simplify this? What is 3 times 2? 6. Plus, so I have 3 times 2 is 6. Now I'm going to look at the second term. 3 times 4 radical 5. How do I simplify that? Wasn't that just 12 radical 5? Yes, no, maybe so. Just multiply the numbers in front, right? Now, so I've done this one, and I've done this one. Let's simplify the third term. How do I simplify 2 radical 5 times 2? What do I multiply in those cases? Just the 2's. Good. So that's 4 radical 5. Good. So I've done the third one now. And how about the last one? How do I multiply 2 radical 5 times 4 radical 5? I don't add anything yet. 2 times 4 is 8. And then 8 radical 25. Don't I have to multiply the 5 and the 5 also? Well, so 8 radical 25. Okay. What's the square root of 25, though? So what's 8 times 5? Isn't that just 40 right there? Okay. Read it. All right, so because the square root of 25 is 5, 5 times 8 is 40. All right, so now I'm just going to write everything else underneath. because if you look, Shamar, there are some things that I can combine. Because I had to distribute it to both of them. 3 times 4. Okay. So I'm going to highlight the like terms in my answers that I can actually combine. I can combine the 6 and the 40. Would you agree?
Yes, ma'am.
The other two things I can also combine are these two. Why?
Because they have the same number of the radicals.
And they're both the same index. Okay? So I can add them. So my final answer is going to be 46 plus what? 16.
25.
Nope. Radical 5. You just leave the radical 5 alone. They're like terms. That is my final answer. So it's not, you see what I mean, Shamar? It actually ended up being just one binomial, right? So it's not really, we had a lot of work to get to it, but we got there.
So that's our goal, is to get a binomial.
To simplify it as much as possible. Most likely it will be a binomial, but not always. Natalia? How to get the 40. Okay, I've answered the same question 3 times. This is the 4th time I'm going to answer it. Everybody pay attention. Where'd the 40 come from?
The 25.
The square root of 25 is 5. 5 times 8 is 40.
Why didn't you just put 5?
Why did I just put 5 there?
No, that's only simplified.
How come that's the only one you did?
Yeah.
Because you can't reduce the square root of 5. I can't reduce the square root of 5. If you can, you need to. Yes.
What if you did?
Yeah, it's not completely simplified. Your answer, the goal is to get your answer completely simplified. Okay?
Hey, look, I have one more question. So for the first one, the 3 goes to the 2 and 4?
Yeah, it goes to both.
Okay, and then the 2 goes to the...
Uh-huh. Yep. You're distributing everything. All right, so I'm going to pull the problems up here on the board. You're going to do the even problems, okay? So let me pull those up for you.